All right, good afternoon or good evening. This is Team AeroDesign with the Seal the Gap Challenge. I'm Ben Witherspoon, and with me is...
This is Cesar Rivera. Hello.
And we've been working with RL Hawk on this. So the challenge is, as everyone knows, first goal is safe transfer of personnel. We have to build a system that allows for safe and balanced transport of operator from vessel to target. And passage must be wide enough for single personnel, and we also must protect the bow area from damage. Of course, the bumper must be able to protect the bow when impacting target vessels, and it cannot permanently be fixed to the bow. Now, for our rules and assumptions, I think everyone's pretty clear on the rules. Kind of a new one at the end was the fitting through the 28 by 28 opening, and of course, everything must fit in the 4 by 4 by 2 max storage volume. Assumptions we had was that no permanently installed provisions or modifications could be made to the host vessel, as well as we were assuming the upper two pin tie-down points are capable of sustaining the 5,000-pound load requirement, and that's in lieu of known hull structural capability. Nothing was provided on that, or for the pins as well, but because of that, we just thought it'd be safer to go with the pins since they were mentioned.
All right, and here's just we'll go over an overview of the design. We have it consists of an aluminum frame, which is collapsible, and it goes together with a series of quick pins. And the forward section of it is the operator platform and an inflatable buoy bag. It has some dampers and gas springs in there, all to work in conjunction to dampen any of the impact from impacting the target vessel. We will have a set of straps running across the inflatable bag that will remain attached, and it will keep the bag attached both in the stowed and in the deployed layout. The frame and the platform will all have several layers of foam applied to the underside to prevent any damage to the host vessel's deck. And then here's a little bit closer, a little more detailed view of the system. At the top right, we have the fully assembled and locked in place platform with the bag fully inflated. Down in the lower section, we're showing a little bit of the frame and platform all in a stowed configuration. All these materials and components will be commercial off the shelf, and once it's collapsed in the stowage configuration, we're making sure it fits into the 4 by 4 by 2 foot cargo volume, as well as through the hatch opening as per the requirements.
Okay, the framework consists of two main assemblies which are unfolded to create the main H-frame structure. They are linked by a set of cross tubes which are connected to the right-hand assembly. So the right-hand assembly has got just two more components than the left-hand assembly. The forward end of the assembly is linked by the operator platform, and those are through 4 quick pins. And this section of the assembly uses 6 quick pins to fully assemble. All of these are tethered to the assembly to prevent accidental loss and aid in a low light operation. So there are 1 pin each for the boat aft pin attachments that keeps it from popping out of that position, and then there's a pin for each of the cross levers you see coming off at an angle from the mid support beams, and the other 2 pins that connect the mid support beams to the between the right hand and left hand support beams as well. Now, once the platform is pinned in place and the entire assembly is complete, the system is pretty much ready to go. The top platform will be an easily replaceable substrate such as marine plywood. It will also be layered with grip tape to prevent slipping, and there will be two quick tension straps are used to attach the inflatable bag to the platform. There will be additional straps going around to the sides to connect to the hooks. They're not shown in the model, but they will be there. And then there's 2 sets of handholds are provided in the platform to allow the operator to maintain stability during impacts as well. He can also use those holes for assembling the device. It gives him a little bit more to grab onto in case a wave hits or something. The inflatable bumper, gas springs, and straps provide the damping capability for reducing the impact loads, and again, these are all COTS items. The bag platform will fold away for storage and future use.
All right, and here recapping back up to the goals that were the initial set of requirements, and we're assuming a two-person operation here. Operator 1, like we said, fully will extract the frame assemblies and the operator platform from the hatch area. He'll be able to unfold the frame assembly and pin it together by himself, even in a no light situation. All the pins will be tethered nearby, near the pin joints or the pin locations. Once he's got the platform pinned to the frame, the only thing left is to inflate the bag. We'll be using the provided air tanks, the 80 cubic foot air tanks, to inflate the one bag. Operator 2's job is to maintain contact with the vessel, and we understand that there'll be some detachment from the vessel, regardless of how hard he tries to keep contact with it. And with the grip tape and handholds, we believe we have plenty of stability for the operator number 1 to prep for boarding the target vessel. And goal number 2 was to protect the bow from damage as well as the hull. Our main source of impact dissipation is the bag, the inflatable bag on the forward side, as well as the damper and gas springs. In case there's the springs and dampers bottom out, we have a secondary set of either neoprene or some kind of elastomer bumpers in between the bag platform and the operator platform to continue to transfer load to the frame and still maintain all load through the frame and not the hull. The frame, we're assuming, or our plan was to make sure to transfer all that load to the pins and use the bottom toe fitting as a resistance to pivoting of the entire frame up and down with respect to the pins that it attaches to. Right now we're accomplishing that with a ratchet strap that just is going to pin to that bow attachment, and the operator will tighten that up as he sees fit. This makes sure that we don't introduce any load into the bow or the hull itself. That was one of the main decisions we went with, try to keep it all away from the bow and hull itself. And
that concludes our presentation. We're also going to finish off with just some of our conceptual sketches, just some of the designs. We originally had a frame structure that did not have a vertical truss component, and we decided that might be necessary given the 5,000 pound load over that very long length, that might want to kick up excessively or possibly down into the hull, damaging the hull. So we added the vertical supports to that, and the platform as well, and kind of the motivation for our design. So if you have any questions, please send them our way.
Thank you.
Thank you.